Okay, what we're going to start with today, we're going to start with week 2 notes. So just to show you week 2 notes, the first problem there we're going to skip. That is in the textbook, so I think it's a little hard to understand as far as like, we're going to start limits today. And I think the problem on the next page, page 3, I think that's a little easier to kind of show you what a limit is. So I'm going to go to another screen and show you what we're going to do as far as like an introductory type of problem to a limit. So the graph that we have is y equals x squared. So the problem says is we're given a point. So here's y equals x squared. So the point is 2, 4. So that's, somewhere right around there. That's 2, 4. So what we're trying to do is we're trying to figure out the equation of a tangent line. So this is what a tangent line looks like. A tangent line touches something in one spot. So here's this dotted line represents the tangent line. So the tangent line touches that graph and at exactly one point, which is 2, 4. So let me draw that again. Okay. So what we want to do is we want to figure out the equation of that line. So we don't know what it is. What we want to do is figure out the equation of that line. So what we need when we write an equation of a line, we need a slope and we need a y-intercept. So the way you get a slope is, if you have a line, is you hopefully have 2 points. Now the problem here, and this is where we're going to introduce a limit, is this line only has one point that we know of. It's 2, 4, which is right here. So what we want is we want the best approximation of the slope of this line, but we only have one point. So now the way we're going to get the next point is we're going to choose a point as close as possible as we can on that curve. So the next point would be really, 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 really close to this other point. As close as we could to get it to there, as close as possible to 2, 4. So this x value, this x value is 2. This x value here is going to be as close as we can get it to 2. So what this means is it means this distance, the distance between these two x values, the distance between these 2 points as far as the x coordinate, is going to be this distance we're going to call h. And as h goes to 0, as the distance for these x values goes to, the difference in them, whatever this x value is, goes to 0. So, for instance, if this x value was 2.000000001, right, that would be really close to 2. So you can see this distance between these 2 points is 0.00001, which is really, really close to 0. So that's what we want. We want these points as close together as possible. That's what we're trying to do to figure out the slope. Then once we have the slope, we just plug in this 2, 4 into our equation with the slope, and then we get the b, the y-intercept. So now let's go back to our notes paper and kind of let's write these points. So what we want to do is we want to figure out the slope first. So like I said, the slope is y2 minus y1 over x2 minus x1. So one of our points is 2, 4. That's x1 and y1. Our other point that's as close to 2, 4 as we can get is this one. So it's 2 plus the distance away from 2, which is h. And remember, we're going to get our next point as close to 2 as possible. So h is going to go to 0. And then our y guy is we're going to plug our x value, which is 2 plus h, into our equation. See, it's x squared. So we're going to square that. That's x2, y2. So now we're just going to figure out the slope. So here's where this limit comes in. The limit as h approaches 0. So our y2, our y coordinate, is 2 plus h, the quantity squared, minus y1 is 4, over x2 is 2 plus h, right here, minus x1, which is 2. All right? So now this distance is going to approach 0. So now all you do is you multiply everything out. So this is 4 plus 4h plus h squared minus 4 over 2 plus h minus 2. All right, keep going. And remember, this is the slope. We're figuring out the slope. It's actually a secant slope because secant is the slope between 2 points. All right, so the limit as h goes to 0. So now we simplify. And on the top, we get h squared plus 4h over h. And then when you do these types of problems for tangent line, you should be able to factor out an h. And then what's going to happen is the h's cancel. All right, so we're left with that. So now remember, h goes to 0. So we're plugging 0 in there. So it's 0 plus 4, which is 4. So our slope, all of these things meant slope. Our slope is 4 because we plugged in h goes to 0. So our slope is 4. The only other thing you have to do then to figure out the tangent line, we got the slope, is you have to figure out your b. So what you're going to do then is you just write y equals mx plus b. Our y guy was 4 from above. Our slope is 4. Our x guy is 2 plus b. Simplify that. So b is negative 4. So the equation of the tangent line, so if you go back here to the picture, this equation of this tangent line is y equals the slope of this line is 4. Put an x there, and then our b was negative 4. So that's the equation of this tangent line. So the limit process was involved in getting a point as close as we could at to 2 comma 4, where this distance from our initial x value of 2 to our other x value is really, really close to 2, where this distance between them is 0. Okay? So the next problem is virtually the same, except that the equation's a little different. All right? So we're going to do the same thing. We're going to find the slope, and then we're going to find the equation of the tangent line. Okay? So here we go. All right. Okay, so our first point is 1 comma negative 3. That's x1 and y1. And then our other point is we're going to plug in 1 plus a little bit away from 1, which we're going to call h. And that's our x value. And then what you do is you take 1 plus h and you plug it in the equation to get the y value. So it's 1 plus h squared minus 4 times 1 plus h. So wherever there's an x, you have to put that in. That's our x2, y2. That's our x2, y2. All right? So here we go. The slope. The limit as h goes to 0. So our y2 is this thing. 1 plus h squared minus 4 times 1 plus h. minus y2, which is negative 3, all over x2. x2 is 1 plus h, right here. And then minus x1 is 1. So let me go down the bottom a little bit here. Right. So the top you simplify, 1 plus 2h plus h squared minus 4 minus 4h plus 3 over the bottom. When you simplified, you see we got an h again on the bottom, which is what we should get. Don't forget to keep writing this limit. So now we simplify the limit as h goes to 0. So we have h squared minus 2h. Minus 2h. All right. What else do we have there? And it looks like the 4's cancel out. I did that correctly. And on the bottom, we just have h. Okay, so we're good. So you pull out, do the limit as h goes to 0, pull out an h, and you have h minus 2 over h. And we're almost done getting our slope. So h minus 2. As h goes to 0, you plug that in there, so you get negative 2. So our slope at that point is negative 2. And then you just plug in that slope and plug in the point to find your b. So y equals mx plus b. So our y guy was negative 3. Our slope is negative 2. Our x guy is 1 plus b. So b looks like it's negative 1. So our equation of that tangent line is y equals, the slope was negative 2, put an x there, and then our b is negative 1. And that's how you do that problem. Okay? So that's the first two things on limits. When we start the next problem on limits, it'll be a little bit different in general. But we'll talk about them as far as a graphic view of that. So there's lots of different types of problems with limits. That was one problem to show you how that distance goes to 0 when we're doing that particular problem.